Alright, so far we have learned how to read the data set, how to handle missing column names, what to do if there are text or information present at the top of the file, and how we can only read in a certain number of rows from the data file. Right, so now when we read in the data, if you had carefully observed, reader actually shows the column names and the column data type, right? It indicates the column data type. Now how does this work, right? Let us explore this a bit, column data types, right? So I'm going to read in the HSB2 file again, okay, and here you can see the column names and followed by the column type, right? It has integer, double, logical, right? Here you can see the column name again, and here below you can see the data type. This integer, this integer, this also integer, this also being treated as integer. Here this is being treated as double because there are decimal values, and here it is being treated as logical because it has, this column has only two values, true or false. So reader may not be able to determine the data type of the column properly. Now in such cases we can specify the data type for each of these columns, right? So we'll see how we can specify the data types. Now before that, I want you to take a look at this function, right? Basically it says spec underscore CSV. Now what this does is, it is not going to, let me clear the screen here, it is actually not going to read the data set for you, right? It will just show you the data types for each of these columns as determined by reader, right? So before you read the data, you can actually run this function spec underscore CSV and then see if reader is able to properly determine the data types for each of the columns being read in. If it is able to determine the data types properly, then you can just go ahead and read the file. But if it is not able to, then you need to specify the data type for each of these columns. Right? Now let us think about a scenario in which you have the data file, right? It has all your columns and rows. Now it doesn't include the column names, right? So it might be that the column names are supplied in a different file, but the data file doesn't include the column names. Now how do you handle this situation? So first what we'll do is, we'll read in a file, okay? This doesn't have the column names or headers. We'll read in that file and see what is the output. And then we'll see what is the solution that we can use to ensure that we get the correct output, or we are able to properly read in the data, right? So we'll call this as column names, and I'm going to read in a file which is in the data subfolder. The name of the file is HSB3, okay? So let me read in this file, and we'll also quickly take a look at this file, okay? Let's go to the data subfolder and we'll open up hsb3.csv. Right, so here is the data set, right? You have the rows and columns, but it doesn't have the, if you go to the top, you can see it doesn't have the column names or the headers, right? And what has happened here is that when the data was read in, the first row, right, you can see the first row here, that is being treated as the column name or header, right? You can see that here. The first row of the data is being treated as the column name, and based on that the data type is also detected. And here you can see some warning messages as well. It's saying duplicated column names have been deduplicated, right? So where the column names were duplicated, they have been deduplicated, which is the case here, right? So 1, and then they have deduplicated it using _1 and _2. Same happens here, 57, and it has been deduplicated using 57_1, right? So here is a problem. You don't have the column name in your file, but when reader is reading this file in the data set, it is assuming that the column names are present, right? And we can figure this out by going here, and you can see the documentation, right? So by default it assumes that column names are present, right? Look at this particular option or argument. It is call underscore names, and it has been set to true, which indicates that the column names, by default, it assumes that the column names are present in the file. Now in our case, the column names are not present in the file, right? So we have to communicate, or we have to indicate it to reader that, okay, in this particular file, the column names are absent, right? And the way to do that is, you read this file and then you use the call underscore names argument and set it to false, right? So what we are saying is that the column names are not present, it is absent. So please don't treat the first row of the data set as the column name, right? So let us see what happens now, right? So the data set is being read in, and now you can see the difference, right? In the previous case, this first row or the first line of the data set was actually present here. It was treated as the column name, but now it has changed, right? Now reader has generated dummy column names, and it is basically X, and then it has appended the column position to X, right? So this first column, second column, so it's X1, X2, X3, and up till the 11th column it has made it X11, right? So now you have the dummy column names, the data types. Again, here you can see now you have all the 200 rows of data and 11 columns. You can again see the dummy column names here, followed by the data type, and then the first 10 rows of data, right? So whenever column names are absent in your file, use the call underscore names argument or option and set it to the value false, right? Now what happens if you do not want to use these dummy column names, right? So X1 to X11. Alright, so the names have been generated, but these are not intuitive, right? They don't say what they represent. These column names are not indicative of what the column is representing, right? So in such cases, what you can do is you can actually create a character vector of column names, and instead of using false here, you can just use that particular character vector, right? So for example, let me say I'll create a new character vector here, right? So we have about 11 columns, and we'll use the original column names from the previous file, right? So let us close this here, okay, and we will take a look at the actual column names, right? So these are the column names, right? So we'll use this here, right? So this is basically a character vector. Let us see the output from this, right? And now what I'm going to do is, instead of using call underscore names is equal to false, I will actually use these column names, right? So data slash hsv3.csv and call underscore names is equal to column underscore names, right? So let us take a look at this output here. So when we indicated that the column names are absent, it created dummy column names X1 to X11. But now that we have created a character vector which basically has 11 text or string for each of those 11 columns, and now we'll use this as the column name, right? So now you can see instead of X1 to X11, you can see the names that we generated here, right? The character vector that we have generated, that is what is being used as the column name. So whenever the column names are absent in your file, the best way to do is to look for the column name in some other file, or probably in some other place where they have provided the column names. Then create a character vector like this, call underscore names, And when you read in the data, instead of setting call underscore names to false, you use the character vector that you had generated to supply the column names for these data. Alright, so now we have learned how to read data from a CSV file, and we have also learned how to handle the absence of column names. Welcome to the course Import Data in R. Now this course is divided into two modules. In the first module, we'll learn how to read data from flat or delimited files, and in the second module, we'll learn to read data from Excel spreadsheets or other statistical softwares. So let us get started with the first module. Here we'll focus on reading data from flat or delimited files. We'll also learn how to handle column names or headers. We'll learn to handle any information or text that is present in the data file, right? So apart from data, sometimes there are other information which is also present in these data files. We'll see how we can handle them. We'll learn to specify the data types for the different columns as we read in the data. And we'll also learn how to skip or select a subset of the columns while we read the data. Now in this module, we'll use the readr package. I have added the link to the website of the package in the learning management system. It is basically readr.tidyverse.org. Here you will find detailed documentation of all the features of this package. So do visit this website so that you can learn more about the readr package. Now before we start reading data, let us quickly take a look at the different types of delimiters that we come across. Right, so one of the most popular ones is the comma, right? So these are comma separated value files. They have the extension .csv. Now apart from comma, there can be other delimiters as well, right? So another delimiter that's used is semicolon, right? So instead of the comma, the columns in the data set are separated by a semicolon. Again, space can be used, right? Using the space bar, you can use one or two spaces to separate these columns in the data set. And finally, the delimiter can be a tab, right? Which is basically 2 or 4 spaces depending on how you define it. So these are the different delimiters that you will come across. There can be other delimiters as well, but I'm just showing the most frequently used delimiters. Now we'll learn how to handle each of these in this module, and we have created files which use these different delimiters so that you can practice with them. But for the time being, let us get started with the CSV files, that is those files where the columns are separated by a comma, right? So we'll read the data in using the read underscore CSV function. So I would suggest you start a new RStudio project, okay? And once you create that project, I want you to go to this GitHub repository or the learning management system and download all these data files, right? So I have added the link to this GitHub repo in the LMS as well, and all these files are also present in the learning management system. I want you to download them and then store them in a folder, right? So create a folder. First you create an RStudio project. You can give it a name such as import tutorial or something. And once you create the RStudio project, within that folder, I want you to create a subfolder. You name it as data and download all these files and save them in this particular folder, right? That is the data folder. So your folder structure should look like this now, right? You have got your RStudio project and you have a data folder within which you have all these files which you have downloaded either from the learning management system or from the GitHub repository. Okay, now we'll start reading these different files, right? So let us start by installing and loading the readr package, right? So you can do that using install.packages, and then within the brackets you specify the name of the package, but ensure that it is enclosed in single or double quotes, right? And once you install the package, you load it using the library function, right? Here you don't need to enclose the name of the package using either single or double quotes. It is done only in this case, that is when you are installing the package, right? Now once you have installed the package, load it using the library function. Right, now let us read a CSV file. Now you can use the RStudio interface to read data as well. I'll show you how to do that. Click on File, come down to Import Dataset and click on From Text Reader. Right, so this will open a new window. The first thing we'll do is we'll locate the file. Click on the Browse button here. Go to the data folder and select hsb2.csv. Right, so here you can see the file name hsb2, right, and it is retrieving data so that it will give you a review of the data. And then here this you can use to skip a certain number of rows if you don't want to read from the first row. Here this one is first row as names, whether the first row of the data includes the column names. Here you can select the delimiter, comma, semicolon, tab, white space, others, right? And if you want to change the data type, right, if you want to specify the data type, here you can click on this arrow, right? So let us start with the first column. Female, as I had said earlier, is a categorical variable, and it includes two levels, which are 0 and 1, but here reader has determined it as integer, so we'll change it. Now let us click on this arrow, come down to factor, and here we'll specify the categories separated by a comma, right? Since the categories are 0 and 1, I'll specify them in this way, right? So the first category is 0, the next one is 1. Okay, right, you can see the code here as well, right? So read underscore CSV is being used, then you can see the location of the file, then it is using the call underscore types argument, and here you can see the name of the variable, which is female, the type, which is factor, and then the levels argument is being used to, right, it is being used to specify the categories of the variable, which is female, right? So here again we can go to the socioeconomic status variable, use factor, and then specify the levels as 1, 2, and 3. Right, so read is being treated as integers, fine. Write is also an integer. Score is double because it has these decimal values, and finally status is being treated as logical, right, because it has true and false, right? So now we can import this data. So you can see the code here, and you can also view the data set on this console. So we have all these 6 columns, and we'll be able to use this data set. So it is your choice that you can write the code or you can use the RStudio interface. I'm showing this at the end because I wanted you to learn how to use these functions in the radar package to read these different file types. But this is also a good way and easy way to read the data. You can use this as well. It is your choice. So try them. Try the different data sets that are available in the learning management system. Try to read those data sets and see how it goes. In case you are having any trouble or any issues, please feel free to reach out to. Alright, so now our data set has about 200 rows and 11 columns. Now let us say you're dealing with some other data which has thousands of rows and you don't want to read all those rows of data in, right? So in that case, you can decide the maximum number of rows that has to be read in, right? And that will be done using this particular argument here, n_max. So by default, it will read in all the rows, but it will display only the 10 rows when you're reading the data. But if we don't want to read all these rows that are present, then you can just use the n_max argument, right? And let us say I want to read just 100 rows instead of 200 rows, right? So now it says, okay, 100 rows into 6 columns. Here I am using the hsb2 file now, not hsb4 or 3. This is hsb2.csv. It has read in the 6 columns and it has read in the first 100 rows, right? The file basically has 200 rows, but we instructed reader to only read the first 100 rows. So it shows 100 rows into 6 columns. and here it shows 90 rows instead of 190, right? So whenever you want to read in only a certain number of rows of data, use the n underscore max argument and specify the number of rows of data that has to be read in. Okay, right? Now let us look at a scenario where you have 10 columns, right? And you just want to read in 2 columns. You don't want to read in all the 10 columns. So one way to do this is again use the call underscore types argument and then use the list function and then specify the data type for 2 columns that you want to read in, and then use call underscore skip for all the other columns, right? Which means you'll have to specify call underscore skip 8 times, right? So there's an easier way to do that. Instead of specifying all the columns that must be skipped, we'll just specify the columns that must be read, right? So let us see how we can do that, right? Here we are trying to read specific columns, right? Again we'll deal with the same data file, which is hsb2.csv, right? And I'm going to use the call underscore, make some space here, right? So we are going to use the call underscore types argument again, but instead of using the list function, instead of giving a list of the data types for the columns, now I am going to just give the columns that must be read in, right? So I want to read in, say, let me say I just want to read in 2 columns from this file. So there are 6 columns and I just want to read in 2 columns, which is read and write. So I'll use the calls underscore only function instead of list. What this will do is it will give the names of columns that must be read in, right? So we are not going to say anything about skipping columns here. We're just going to say, okay, all the columns that have been specified here, you just read them and leave out the other columns. So I want to read in the read column. So I'll specify the column name followed by the data type and the write column, right? So again, I'll specify the column name followed by the data type. Now let us read this in, right? So again, you can see here, it just read this 2 columns. So we had asked reader to read 2 columns. Okay, we specified the name of the column that must be read in followed by the data type of that column, right? Here read and write, and both of them are column integers. So when you're using calls underscore only, specify the name of the column as well, right? So you should know the name of the column and you should also specify the data type of that column, right? So this is better when you have, say you have 10 or 20 columns in your data set and you only intend to read 2 or 3 of them, or say 3 or 4 of them, right? So that you don't have to keep on specifying call underscore skip for the other columns. Now in case of skipping columns, it is better to use that when you have, say, 10 or 20 columns and you just want to skip a couple of them, right? So use call underscore skip within the list function when you have a large number of columns and you want to just skip a couple of them, and use the calls underscore only function when you have a large number of columns but you want to read in only a couple of them, right? That way it will save you a lot of typing and also save a lot of mistakes because you don't have to keep track of the number of columns that you have to skip. Alright, so now we have learned how to specify the data types for different columns. Now what if you don't want to read in all the columns in your data set, right? Say, let us say we have 6 columns, right? And I don't want to read in the first 2 columns. Those categorical data, I'm not going to read them in. I just want to read in the last 4 columns, right? So let us see how we can do that. So here we are basically trying to skip some columns. So we'll read the same file, read underscore CSV. It's in the data folder. So hsb2.csv here. And then now again, I'm going to specify the column types here, right? Even when you're trying to skip data, use the call types argument, use a list function because you're going to give a list of data types. But instead of using call underscore factor, I'm going to tell reader to skip this particular column, right? I want to skip the first 2 columns. So I'm going to use call underscore skip twice. The next 2 columns are integer. So we'll use call underscore integer for read and write. Score is numeric or double because it has decimal points, so we'll use call underscore double. And finally status is logical, right? It has true and false values, so here we'll use logical, right? So let us read in this data set. Right, so now you can see it has just read in the 4 columns, right? We have 6 columns in this data set, but we said that we want to skip the first 2 columns, right? And we used call underscore skip to indicate to reader that the first 2 columns must be skipped. Here you can see it has skipped those first 2 columns and it has just read the last 4 columns, right? You can see there are 200 rows. Now don't worry about these warning messages. They'll be coming. You don't need to worry about that. There's no issue there. But remember this, when you want to skip a column, use the call underscore skip function within the list. Now let us look at another scenario, right? So in this case, your file is having the column names, but it is also having some other information, right? So I'll go to this particular folder here, hsb4.csv. Right, so here you can see the data is present from here. It includes the column names, but there is a bunch of other information that is present before the data begins, right? So here you have the description of the data set, from where it is coming, what is the name of the variables, what is the type, what values it includes, who holds the copyright, and all those information, right? And when you are reading the data, you don't want this information to be read in, right? So when reader starts reading the data, you don't want this part to be read in. This is just for the user information. You want to read data from this particular row, right? So what do we do in this case? Now suppose you just read this data set. Now if you just read the data set without sort of handling those information that is present in the file, you will end up with a lot of warnings and errors, right? So we'll see what happens in such case. So let us read that particular data file, hsb4.csv, right? So I'm not indicating anything else here. I'm just trying to read that file, and then you can see a lot of errors and warnings here, right? So you don't have the data actually. You end up with a lot of NAs here. That is basically for your missing values or values which are absent. And you can see here the HSB2 data set is taken from a National Survey of High School, which was basically the user information which was present at the top of the file, right? And here it says 225 rows, our data has only 200 rows, and then here it says missing column names are filled in, right? So you can't actually work with this data set. You can't do any analysis with this particular data that has been read in. So one option here is that you can use this particular option, which is skip, right? Or if you go down here and read underscore CSV, you have the skip argument, right? And using this, you can actually skip a certain number of rows, right? And then reader will start reading data after skipping a certain number of rows which you have indicated. Now in our case, let us see how many rows we will have to skip, right? That's the number of rows occupied by this particular information we have here. That would be about 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? So the information here is present in the first 25 rows. And if we want to properly read in the data, we'll have to skip the first 25 rows and then we have to start reading the data, right? So let us try this. I'll read the same file, but this time we are going to skip the first 25 rows, right? So now you can see that the data has been properly read, right? So you can see the column names. You can see the 200 rows into 11 columns here. All the column names are correct. We have the first 10 rows of data, and it says there are 190 more rows. right? So whenever you have some data file which has information present before the actual data starts, look for the number of rows it occupies or covers, and then skip those many rows while you are reading the data, right? So in our file we have 6 columns, right? And now we'll learn how to specify the column type for each of these 6 columns, right? So now when you're reading data, you might come across these different data types, right? One is integer, which doesn't include the decimal values. Double is those numbers which include decimal values. Logical is when you have true or false as your data in the column. Categorical data will include levels, right? This can be like gender, male, female, or education levels like primary, secondary, tertiary, and professional. Um, if your data includes text or string, then it is character. If your data includes date, time, or both, then it is of data type date time or date or time. And then last one is where it's not a data type, it is something that can be used to skip a particular column when you are reading your data, right? So whenever you want to specify a particular data type for a column, you'll use the appropriate function, right? So for integer, you will use call underscore integer. For double, call underscore double. Similarly, call underscore logical for logical values, and so on, right? So we'll see how we can use these functions to specify the data type as we read in the data, right? So one thing that we'll see is how to specify the column types, how to skip columns, and how to read only specific columns, right? So the call underscore types function will be used to specify the column data types. Call underscore skip is going to be used for skipping a column, and calls underscore only is going to be used for reading specific columns, right? So we'll start with the first part where we want to specify the column types. Okay, so let us read in this data set again. Read underscore CSV. We bring this to the middle, and then we'll specify the data set. Right now I want to specify the column types, right? So we have 6 columns and I want to specify the column types. Let me just read in this file here once, right? So here you can see the values, right? And if you look at this particular column, first one, female, it is basically a categorical variable or data, right? It takes only 2 values, 0 and 1, and this should have been treated as a categorical variable or qualitative variable, and the data type here should have been call underscore factor, right? So we'll set this right now. So to specify the column types, you will use the call underscore types argument, right? So let us use it, call underscore types, and then you have to specify the column types for each of these 6 columns, right? And you will supply that inside a function called list, right? So this is a list of data types for each of the columns present in the file, right? So now I'll specify 6 data types. So first one has to be call underscore factor, and then within this I'll specify the categories of this particular variable, right? So for example, in the first column here, the variable female, it has 2 categories, right? 0 and 1. So I'm saying it is a categorical variable and it has 2 categories, right? And the categories are specified using the levels argument, and here I specify the categories which are 0 and 1, right? So I specified the first column. Now let us go to the second column. This is also a categorical variable. So SES here stands for socio-economic status, and it has 3 categories, right? 1, 2, and 3. So again I'll use the call underscore factor function, and I'll specify the levels as 1, 2, 3, right? The third one is, of course, it is an integer. So I'll use call underscore integer. The fourth is also integer, which is right. So again, you use the call underscore integer function. The fifth one is numeric. So I'll use call underscore double instead of numeric here because it has decimal values, right? And here you can see the data type is DBL, which is basically double. So whenever you have decimal values in the column, use call underscore double and not call underscore integer, right? And the last one is logical, right? Because it has true and false values, and those are logical values. So we'll use call underscore logical, right? So now let us read this data, right? So here now you can see the difference, right? So when we read the data without specifying the column types, female and socioeconomic status were treated as integers. Now that we have clearly specified that these are categorical variables and we also specified the categories, they are being treated as factor data types. So factor data types represent categorical or qualitative data in R, and we have a separate course where we'll see how to create them and how to handle them, right? So here instead of integer we can see factor, which is FCT, and the next two columns are integers, so you can see they're being treated as integers. Then for score we specified double because it has decimal values, and for status, which has true and false, we have used call underscore logical, right? So whenever you're reading the data set, use spec underscore CSV to see if reader is able to properly determine the data types for each column. If it is not able to do it, then use the call underscore types argument. Use the list function basically because you are giving a list of data types, and then start using these functions, right? Call underscore integer, call underscore logical, call underscore double, you have call underscore factor, you have call underscore date, time, or date and time. So date and time we'll deal with them later as we come across those types of data. But for the time being, I think this will help you because you will be reading in a lot of categorical data and you should know the right way to read them. Now let us come to this part, right? Here we have specified the folder name, subfolder name, and then we are specifying the file name and the extension. Now regardless of where your file is located, the name is going to be the same, right? It is going to be the HSB2 file with the extension CSV, but this file can be located in different places, right? So for the time being it is located here within the data subfolder, right? So this is my main folder course. Here is the RStudio project, and then the data set was located in this subfolder, right? Data folder, you go in here, look for hsb2.csv. Now if the file is located in the same folder, right, so it is in the same folder as your RStudio project, then you don't need to specify the subfolder or anything else, right? So let us say file is in the same folder. In this case I'll just use the name of the file, right? Because here we are specifying the path relative to the RStudio project. All it will do is it will look for this particular file in the same folder. If it finds it, it will read the data for you, right? In this case we had to specify the subfolder within which the file was located, right? So we said, okay, go into the data for subfolder, look for hsb2.csv and read it in. Now what happens if this is in a different folder, right? So for example, so here I am in the G drive and then in the course folder, right? This is also where my RStudio project is. What if my data is located here, right? It is not in my RStudio project folder, it's in a different folder. So now I'll have to specify this location, right? And there are two ways to do it, right? So let us try this. File is in a different folder, right? So now I'll specify read underscore CSV, and now I have to tell RStudio, okay, go up one step, right? And that I can do using two dots, and then I'll say go into the data folder, which is this one. Okay, and look for hsb2.csv. right, let us see if this works. Right, it did work, right, because we indicated, or we instructed RStudio to go up one folder. That is, from here we asked it to go up one folder, that is using the two dots, right, and then we asked it to go into the data folder and look for hsb2.csv. right. Now if this is confusing, there's another alternative, right, where you will specify the full path. So let's say read underscore csv, and then you'll specify the full path of this file, right. So it's basically G, go to the G drive, go to the data folder and look for hsb2.csv. right, it still works. So either you can specify the full path starting from the drive and then the folder, subfolder and the file name, or you can specify the path relative to your RStudio project. Now in each of these cases I can specify the full path, right. So for example, here I can say read underscore csv, G drive, go to course folder, go to the data subfolder, then look for hsb2.csv, and you can read it in, right. Even in this case, right, so read underscore csv, so go to the G drive, go to course folder and then look for hsb2.csv. right. So the multiple ways in which you can specify the location of the file. The best way to do is to specify it relative to your RStudio project, if you can, if it is in the same folder, if it is in a subfolder, or if it is an adjacent folder, right. In that case you can specify these relative paths, right, these three relative paths. Or if you don't want it to be confusing, or if it's a completely different drive, then the best way to do that is to use the complete path, right. So specify the drive, then the folder, then the subfolder, and then you can specify the name of the file along with the extension, right. So now we have learned how to read data into our simple CSV file. We also learned how to specify the location of the file. Either you can specify the complete path or you can specify it relative to your RStudio project. Okay. Okay. So I'm going to use the read underscore CSV function. Okay. And then I'm going to specify within the brackets, I'm going to read this particular file now, which is hsb2. Okay. Now it is also present here in the same folder, but I'll tell you the reason why it is there and what we'll do with it. For the time being, I want you to read the data file, which is hsb2, from the data folder, which is the data subfolder, right. Here it is. Now as we read the data, we'll also learn how we specify the location of the file relative to the RStudio project. Okay. So first let us read the data. So I'll specify the path, that is, go to the data folder or the subfolder, look for hsb2 file with the extension CSV and read it in. Right. So here you can see the output. So first it says pass with column specification. You can see the names of the columns and the data type as detected by reader. Okay. And then you can see the number of rows and columns. It is 200 rows, 6 columns. You can see the name of the columns again here, followed by the data type, and then the first 10 rows of the data are displayed here, right. And it says there are 190 more rows. So this is a basic sanity check that you can do by looking at the information here. Look for the name of the columns, for the data types, look for the number of rows and columns, and if all of them have been read or not, right. So this is how you'll read a file using a read underscore CSV, right. So that brings us to the end of this module, and we have learned how to read data set, right. So we started by reading data set, and we also learned how to specify the path of the file. Either it can be relative to your RStudio project, or it can be the absolute or full path. And so then we saw how we can handle the absence of column names using the call underscore names argument. And we also learned how we can supply a different set of column names using the same argument. We also learned to skip lines using the skip argument, and we also learned how to read in a certain number of rows of data using the n underscore max argument. Then we use the spec underscore CSV function to see if reader is able to determine the data types of the columns properly. We also used call underscore types argument to specify or list the data type for each column, to skip certain columns, as well as to read in only a specific subset of the columns in the data set. Now in the next module, we'll deal with Excel spreadsheets and data files from other statistical softwares. Now all the code and all the data sets are available in the learning management system. The data set is also available in the GitHub repository, and all the code files are also available in GitHub. So you can download and use them. If you have any doubts or confusions, please go to the Reader website, that is reader.tidyverse.org. You can go through the documentation here, but if you still come across issues, please feel free to reach out to us and send in a mail to support@rsquaredacademy.com.